everyone. My name is Minjing. I'm a second-year PhD, and it's my great honor to share this my summer research with all of you. And it's a framework for specializing LLM for auditing. So why it is important to specialize it? We all know how powerful those LLMs are. However, they're not a plug and play for auditing, because in auditing, accuracy, compliance, and domain understanding, they are not optional, they are mandatory. So to help them better understand the context, the goals, and the constraints of audit work, we need to specialize them. So the problem with general LLMs are, first of all, they use outdated knowledge because they are trained on the historical data. Therefore, they have a cut-off dates. So the freshness is a problem. And also their lack of professional judgment, because they were not trained on such context. And they only have a superficial understanding of the audit standards, and they might be unable to follow from specific audit methodologies. So because of these problems, when we are using general LLM without specialization, they can lead to hallucination problems. They generate those plausible but actually not true or very risky answers for us to use, or they might have misinterpretations of the regulations, or when we use them for risk detecting, they might fail their work. So there are a lot of methods for specializing LLMs. To get a better understanding of them, we can think of LLM as black box or white box, depending on the accessibility to those LLM parameters. For those that we cannot tweak their parameters and we cannot have many interactions of them, we call them black box. We use them as a black box because it feels like we don't know anything inside the box. So in this kind of LLMs, when we are specializing them, we usually use RAG, mentioned by Bu He, that is retrieval augmented generation. So that, to put it in human words, we use an outside knowledge base, for example, a document. So when we use it for some tasks, we use LLM to first consult those database, the outside database. And we can also not only use databases, we can also use outside tools like domain tools. We can use LLM to call those domain tools. So these are all all strategies, approaches we can use with black box LLMs. And for those white box, meaning we can tweak all those parameters, we can use fine tuning. I'm going to skip those technical details. And for those between, we call them gray box. For example, when we use GPT-3, we can set the temperature to a high temperature or a low temperature, meaning to control the randomness or creativeness that you want. So these are called gray box, and these we can use prompt engineering with this. Actually, this is just one way to categorize those methods for better understanding. It can be categorized in other ways if you like. So our goal is to build a framework to specialize those LLM for audit tasks. Therefore, they'll better understand the audit objectives, the regulatory requirement, the firm-specific practices, and risk material threshold. We can think of it as train the AI, train the LLM intern into a seasoned audit associate. So how do we do it? We follow a four-step approach. Because this research is still at an early stage, so this framework is a simplified one. It is a very common approach when we are doing this kind of research. First, to identify the scope, to define the audit domain and use case, and signal to inject domain-specific data and knowledge, for example, audit standards, internal firm methodologies, historical engagement, relevant client context. And in this process, we might use, for example, RAG, or we might also use fine-tuning depending on the cost and benefit analysis. And then the steer to control model behavior to align with all the objectives and constraints. In this process, we might also use prompt engineering, and we might also hook LLM with some outside tools for example, threshold or rules controls. And the fourth step is scrutinize we evaluate those audit-specific metrics, their accuracy, their alignment with audit assertions, and usefulness and interpretability for documentations. And as I mentioned, it's still at an early stage, so it has some problems or limitations that needs to be further developed. For example, the data access barrier because audit data is sensitive and it's usually hard to generate enough domain-specific data for training. And evaluation challenges, it's hard to define what a good LLM answer looks like in complex audit tasks. And regulatory uncertainties, those guidelines on using AI in audit is still emerging, and firms must balance the innovation with compliance. And most importantly, cost and benefit analysis. Implementing LLM in auditing involves significant cost, model acquisition or training, infrastructure, security, fine-tuning, and staff training. And the benefits, we really need to calculate or develop a model to evaluate the benefit and cost for better implementation. And the future research opportunities are, for example, audit-specific evaluation metrics to develop some scoring rubrics based on audit quality indicators like documentation clarity, risk identification accuracy, and reviewer usefulness, and maybe hybrid systems to try to come up with some combined LM with audit tools or structured checklists for more robust, explainable outputs, and human AI collaboration workflows to explore how auditors interact with LLM during field work and review which part builds trust and what causes friction, and how to ensure responsible AI in auditing, how to document, audit, and govern AI use internally to satisfy regulators and stakeholders. And that's all for my presentation. Thank you very much. Please feel free to send me an email for any further discussions. Thank you.